This episode of Photonics Hot List is brought to you by Aerotech, precision motion control and automation. Take control, speed, precision, performance.
Hello, I'm Justine Murphy, Senior Editor of Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Researchers in Scotland are entering uncharted territory to see more of what's really happening within live cells. Using stimulated Raman scattering, or SRS microscopy, a collaborative team from the University of Strathclyde and the University of Galway can now acquire clear images of individual cell processes in a shorter span of time than ever before. The team's approach combines SRS microscopy with spectral phasor analysis, in which the fluorescence emission spectra of each individual pixel in an image essentially acts as coordinates that correspond with those pixels. Signals obtained from each of 3 different Raman reporters the team used can be readily unmixed using that analysis on hyperspectral SRS images. As a result, the researchers can now isolate 9 discrete regions of interest from the cellular SRS imaging dataset label-free. Unlike conventional fluorescence microscopy methods, the new approach uses bioorthogonal tags, labels that do not interfere or interact with cell function. The researchers are now working to expand their range of bioorthogonal tagging to enhance cellular imaging and sensing applications, which could lead to a better understanding of how specific diseases behave. Solar cell farms and photovoltaic plants are among the top players in environmental sustainability efforts, so inspection of their components and processes to detect things like early-stage failures, defects, and degradation is crucial. But the level of accuracy offered by existing approaches, such as infrared imaging, is lacking. So, a collaborative group of researchers is taking to the skies to address it. Teams from First Light Imaging and Optoprim, both in France, as well as Denmark-based Creative Sight and the Technical University of Denmark, are developing a drone-based technique called laser-induced photoluminescence imaging. The technology features a GPS component, an industrial-grade shortwave infrared or SPIE camera, and a line laser, all integrated into a drone. The contactless approach works by injecting luminescence into solar cells. This is then captured by the SPIE camera, which is sensitive to the spectral region where light is emitting from those solar cells. The combination of technologies enables extremely high-quality, high-resolution imaging at up to 600 frames per second in full frame. The team is now looking to take this unique system from proof of concept to commercialization. Researchers in Sweden are breaking barriers and long-assumed fundamental limits of optical conversion efficiency with significant improvements to Soliton microcombs. This could greatly expand high-performance laser technology into all kinds of markets, they say, from environmental sensing drones to artificial intelligence. The team from Chalmers University of Technology has designed advanced Soliton microcombs, essentially rulers made of light that are generated when a continuous wave laser is brought into the resonance of a high-quality microresonator. The new microcombs overcome a long-standing fundamental problem, weak conversion efficiency between the laser and the microcomb. Only a fraction of that laser beam's power was ever usable before. In their work, the researchers have increased the laser power of a Soliton microcomb tenfold, in turn boosting the efficiency from about 1% to more than 50%. Some fundamental aspects of the new Soliton microcomb design continue to be explored, the researchers say, but the technology could someday be used for applications like telecommunications, optical sampling, and spectroscopy. SPIE's Photonics West is right around the corner, and among its most anticipated events is the annual SPIE Startup Challenge, a showcase of some of the most innovative technologies and applications developed by early-stage startup companies. From a pool of 7 finalists, the top 3 will be chosen by a panel of judges that's comprised of photonics industry venture capitalists and business development experts. This week, the 2024 finalists were announced. They include ClearVision and its creation of a non-invasive alternative to permanent vision correction surgeries that uses femtosecond laser technology for corneal sculpting, a laser projection-based manufacturing machine by Momentum Optics designed to eliminate the need for specialized tooling, molds, or photomasks, technology by Photonics that decreases the insertion loss between a photonic chip and an optical fiber for a 4-fold improvement over existing industry standards. Perovskite-based photovoltaic modules from Solaire's Enterprises that can recycle indoor light to power battery-driven devices without connecting to the grid. A next-generation lens array by Solid that's coupled with a light field display for macular degeneration vision correction. A real-time inspection solution by Track that uses terahertz radiation and metamaterial technology for printed electronics. And a lens-free imaging solution from Urimetrics that can reduce the incidence of catheter-associated urinary tract infections. Good luck to all of the finalists. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, and visit laserfocusworld.com for the latest and coolest news and information. Until next time.